Please welcome Nicola Curry, Oxford University Hospital.
Hello, I'm here to introduce the company ThinkSono, who I think should win the Scientific Startup Award for 2021. My name's Nikki, I'm a blood specialist, and I particularly look after patients who clot too much, and particularly those patients who develop clots in their legs. Diagnosis of clots is usually done by an ultrasound scan, and this needs X-ray specialists, of which there aren't many, and therefore diagnosis is challenging and can be slow. ThinkSono, who I've worked with now for a few years, have developed a revolutionizing technology that will allow people like me and non-X-ray specialists to diagnose patients with DVT rapidly and very easily. This will alter and revolutionize the care of up to 1.5 million people every year across the world, and will change the face of these treatments. I think that ThinkSono are amazing. We have published in Nature quite recently about the work that we've done. We're about to open a multi-center clinical study to confirm that this technology is as good as I think it is. For these reasons, I think ThinkSono should win this award.
Breaking the wall of detecting deep vein thrombosis. Fuad Noor, ThinkSono.
Hello, my name is Fuad Al-Noor. I've said it several times at this point, so I'll just move forward. I'm the CEO of ThinkSono, and as you guys can see, we're trying to break the walls of detecting deep vein thrombosis. Now, for some context, deep vein thrombosis is the #1 cause of preventable hospital death in the world. So what happens is you get a blood clot formed in the deep veins of the leg. When part of that clot breaks loose, it goes up to the lung and causes something called a pulmonary embolism, which is actually what leads to death most of the time. And as you can see in that slide, it's, the combined deaths of DVT and PE is more than breast cancer, AIDS, and car accidents combined. So this is a real big problem. An additional part of this problem is that, as Nikki said, you need usually a radiologist or an X-ray specialist to use ultrasound devices to diagnose a patient. That itself has multiple problems. So we're the first company in the world that's been developing a solution for this problem, and you can see the solution in the next slide. This consists of literally an Android app. You can download it on your Android phone, and using this app and a compatible handheld device, a nurse or a non-specialist can scan this patient and find out if there's DVT in that patient. And the scan can take as little as 5 minutes, 5 to 15 minutes. And then some of these images can go up to the cloud and get reviewed by a radiologist if required. And we can go into that in detail later on. But here is the actual example of the technology working, and I'm really hoping this will work. If I click next, oh, no, it doesn't. Okay, fine. So on the sort of right-hand side, you see green, that's the vein, and then on red, there is an artery. And what happens is our software analyzes veins and arteries, provides real-time guidance to the nurse. Oh, it actually did work. Okay, that's great. There, real-time guidance to the nurse to detect the correct veins and arteries. To detect DVT, you need to compress, which is what it suggests there. And if there's a full compression, there's no clot, there's no thrombus in that vein. That's basically how it works. And in a second, the software will analyze this compression, check if it's correct, and then give the user essentially a decision whether or not there's a DVT there, as well as an automatic AI analysis whether or not there's DVT. So we can go into that in detail as well, and who makes the decision, etc. But I'll just let it finish there, just to prove the point. And then in this case, there's no DVT. The person can move forward. So one of the big problems of the diagnosis, as I said, although it's very important, the current diagnostic pathway is quite long and complicated. There are multiple touch points in the healthcare system. It involves a trip to the emergency department, a risk assessment, a D-dimer blood test, and then you get the ultrasound specialist, then you do that scan that I literally just showed you. So what we did was we said, well, if we implement our system, and that's in the Nature paper that we published recently, the pathway can go from 6 to 24 hours down to 15 minutes. And in fact, you improve patient outcomes and you can reduce the cost of the entire process, as you can see, but also you can do the scans outside the hospital settings if you wanted to. That's your general practitioner's office and other outpatient centers. So it can essentially transform the way the management and diagnosis of DVT happens. Even with certain patients like cancer patients, post-op patients, pregnant patients, all of those patients that are at high risk of DVT, you can scan them without having to send everyone off to the radiologist, essentially. We know it's safe as well because it's compression ultrasound, which they literally do today, so we're following the standard of care anyway. Obviously, we're not doing this alone. As you can see, we're working with Oxford University Hospital, but multiple other hospitals, including hospitals in Germany, for example, Ernst von Borgmann Clinic in Potsdam as well. And we're backed by the Wellcome Trust, as well as we've got some EU grants as well. And we're partnered with a handheld ultrasound vendor that you guys saw. We're actually hardware neutral, but we do have partners that we use their hardware. And one of them is Clarius. So these are inexpensive handheld devices. And there is a little bit about the market. It's very simple, actually. We're a SaaS product, essentially. We charge a license fee for the hospital. The cost of the license is based on the health economics we did, which is also in our Nature paper. And we worked out we can charge them $50,000 to $200,000 a year, depending on the size of the institution. And that works out to be more cost-effective than what they do today. In fact, I could arguably increase that cost, but we're just making a very rough estimate. We're not in the market yet. We're still in clinical trials, which is why this isn't as detailed as it should be. It will be in the next 12 to 18 months. We will be going commercial then. And obviously, you can read that in our Nature paper. It's not just me. We have machine learning scientists, engineers, software engineers, like my co-founder Sven, as well as hematologists, vascular surgeons, and commercialization staff and advisors as well, obviously, who can support us to take this product into the market. And with 11 or 10 seconds to go, I'd love to take your questions. Thank you.
Wonderful. You do my job now. This is great.
Go for it.
Okay, let's take questions. First, we have Frank here in the first row. Then we will have also a second question here.
So did I understood correctly? This is a diagnosis support tool. The diagnosis is done by the physician.
It's like listening to the FDA at this point.
Yeah.
So technically, the nurse collects the data. Well, there's different claims you can make depending on the size of the study you have. Theoretically, yes, the software can just make the entire decision on its own. But we're not yet claiming that's a big claim to allow AI to do stuff like this. So what we're currently doing is we're doing the scans and they're being reviewed by a radiologist, and then that's technically the diagnosis then. The nice thing here is that they don't have to go to hospital, and the economic argument stays pretty much the same. But in the future, in our next multi-centered clinical study, we want to do a non-inferiority study. And in that case, you can have the full-blown decision done without even transmitting the data. So there are two versions, is what I'm trying to say.
And you have a comparison data that you compare
Of course.
this diagnosis to typical
the standard of care.
Doppler sono.
Yeah.
And what is the specificity?
So we have already in our Nature paper shown above 90% sensitivity and above 80% specificity. As you would imagine, sensitivity, which is missing the clot, by the way, 100% would be perfection. You don't want to miss the clot. It's less of a problem to say there's a clot than there isn't because you can get checked, etc. In any case, the sensitivity is above 90%, at least in the first paper. And that's what we're trying to also revalidate in our multi-center prospective clinical study. So we're working on making sure that that's true. Go on. Sorry.
Thank you. Next question, please.
Maybe you could elaborate a little bit on your more cost-effective for the hospitals, because of course usually they have some reimbursement schedule. So
Right.
what is happening? Do they get more
Yeah.
reimbursed and have lower cost, or how does it work?
Yeah, so the reason it's more cost-effective, as you could see that clinical pathway shortened, to put it very simply, even if you just remove that D-dimer blood test I mentioned briefly, which is sort of trying to do this, but it doesn't really work very well, as a minimum, if they can just avoid doing this test, it's already cost-effective. But it's more cost-effective than that because you don't need that radiologist either to do the scans. So now you're removing two big components. In fact, the patient doesn't even have to go to hospital, which is another expense. So usually just being in the emergency department is quite expensive. Now, sorry, that's a good question. It depends on it's actually healthcare system that I use. In the NHS, they don't have insurance based. In Germany, they do. So it's more expensive. In any case, actually, the reimbursement doesn't even cover a lot of these costs anyway. So even for the hospital, it's expensive. But to put it simply, we may still get reimbursement anyway. So there's currently a compression ultrasound reimbursement pathway in Germany, in the US, and in the UK. So we can potentially fall under the same reimbursement billing code that they use for ultrasound already. So they basically don't pay anymore, or they might even earn more money using our technology, actually. But I wouldn't push it that far yet.
Okay.
Yeah.
Thinking about what the symptoms are and what the other diagnoses might be, how would this potentially change where you are on the decision tree?
Right.
Is it this, then that kind of thing?
Yes.
Because it's not this, what else could it be?
Well, it's a very good question. So the way it works actually is, Currently, they basically look at you, say, oh, you know, do you have a swollen leg? Are you pregnant? Okay, we have to send you off. And that's what happens. So something like 88 to 95% of all ultrasound scans for this condition come back negative, because you're not going to risk the clot on the patient. You're going to send them for a scan. And what we're saying is, even if we just say exclusion, you don't have DVT, and if you maybe do, then we'll send you off. Even if it's imperfect, it's better than whatever exists. That's why we're so confident, because we're using the top gold standard to make to make it essentially just more efficient and more accessible. We have 5 more seconds. I apologize. I can't go into much.
Yes, I'm really sorry. We cannot take your question, but they were first.
Okay.
Okay. Thank you very much
much
for this session.